Good morning. Today's lesson is about addition and subtraction of radicals. So the only way we can add radicals if the indices and the radicands of the given radicals are the same. Index is here and radicands, they're there. So once we see that the indices and the radicands are the same, we can do the indicated operation on the coefficients. Let me give you examples. So 2 square root of 5 plus 5, or sorry, square root of 5, they have the same indices. The index is 2. It's here, it's square root. So both of them are square root. And the radicands are 5. So we can perform the operation here. It's 2 plus the numerical coefficient of square root of 5 is just 1. There's a 1 there. So that means this is equal to 3 square root of 5. For the second example, 5 minus 8. We can perform the operation because now we can see here that the radicands are the same and the indices are the same. So this is just negative 3 square root of 3. So we perform the operation on the coefficients and just simply copy the radicands. Let's go to the third example. 3 or negative 3 square root of 5 plus 4 square root of 45 minus square root of 20. Now here, it may seem like, oh, we cannot add these three radicals because the radicands are different. But wait a minute. I can see here that 4 square root of 45 is not in simplified form. So that means we need to simplify that. Also, square root of 20 is not in simplified form. So we need to simplify that. So simplifying radicals come into play here. So that means you need to know how to simplify radicals. I cannot simplify this radical anymore, so I can just write it there. Plus 4. Now, square root of 45, to simplify that, you need to find the highest perfect square factor of 45. And that is correct, it's 9. So square root of 9 times square root of 5. Minus, when it comes to the square root of 20, the highest perfect square factor of 20 is 4. So this is the square root of 4 times the square root of 5. All right, so now this will be equal to negative 3 square root of 5 plus, what is the square root of 9? It's positive 3. We multiply that to 4. That gives us 12 square root of 5. Minus, this is just square root of 4, which is 2. So 2 square root of 5. Now here, we can see that the radicands are the same, and obviously the indices are the same, right? So we can perform now the indicated operation among the numerical coefficients. So negative 3 plus 12 minus 2. And that is equal to 7 square root of 5. Okay? Let's go to the last example. Again, just like in the previous one, it may seem like, oh, we cannot add these 4 radicals because they have different radicands. But wait a minute again, we need to simplify all of them first before we decide the radicals that we can combine or we cannot combine. So let's say the first radical. So 5 square root of, okay, simplify this by identifying the highest perfect square factor of 63. That is right, it's 9, so times square root of 7. Minus 4 square root of highest perfect square factor of 28 is 4. This is 7. 4 times 7 is 28. Plus highest perfect square factor of 700. I think that is all obvious. It's 100. Minus the highest perfect square factor of 40. That is again 4 times the square root of 10. So let's simplify all of this now. Square root of 9 is 3. Multiply that to 5. That gives us 15. Square root of 7. Square root of 4 is 2. Multiply that to 4. That gives us 8. Square root of 2. No, square root of 7. Right? Plus square root of 100 is 10. 10 square root of 7. Square root of 4 is 2. So 2 square root of 10 equals. I think we can combine these 3 radicals, but we cannot combine this 3 to the fourth one because the fourth one is square root of 10. So meaning this is 15 minus 8 plus 10. That's 15 minus 8 plus 10, which is equal to 17 square root of 7 minus 2 square root of 10. Again, we cannot combine these two radicals because although the indices are the same, the radicands are different. So which means that this is our final answer. Oh, what happened? There you go. All right. Thank you for watching and please do subscribe to my channel. Have a nice day.